Hello. So in this is the second half, I believe, of lesson 13. And so now we're going to talk about formula substitution. So unlike the last one, unit conversion, that happens a lot in chemistry and also in physics. I didn't mention physics as much, but it does happen there. Um, Formula substitution is just something that kind of works in all of the sciences. Like every single place you go where there's an equation of some kind, they're usually doing formula substitution to make their lives a little bit easier. So the basic idea of formula substitution is just the idea. It was kind of like at some point we were doing function composition where we just plugged one function into another one. So what you're going to see is that happens a lot. And so we're going to go ahead and go to the board so that we can look at an example of what that looks like in action now. So let's say we have three different equations. So let's say we have a equals, let's say 3x y. So a equals 3 times x times y. So you go, okay, so I can't solve for anything here because, everything's plugged in. Or not everything's plugged in. Sorry. There's not enough things plugged in. We have a variable a, x, and y. So I would need three equations in order to solve this, right? And then, yeah, you would. So let's give you another equation. So let's say 300 is equal to, let's say, 2x plus 5y. So now we're starting to pick up some stuff. So now we could get x or y by itself. But even if we could right now, we don't know what a is. So it's not really a big deal trying to figure that out. So let's do another one. Let's say that 10a minus 3x equals 400. Okay, now we're cooking with gas. Now we've got three equations and three variables that we need to work with. So we need to somehow make all three of these guys relate to each other so that we can solve all three of them. So what we're going to do is we're going to pick a letter that is in all three of them. And we're just going to solve for that. So we have x is in every single one of these. So what we're going to do is we're going to make all of these x equals. Because once we can make them x equals, we can start replacing and moving things around much easier. So you don't always have to make it the same letter for everything. It's just that in this case, we know that x is going to work. So let's go over here and let's get x by itself. So x is multiplied by 3 and it's multiplied by y. So if we divide by 3 and y on both sides, we'll get x by itself. Okay, so cancel that, cancel that. So x is equal to a over 3y. Okay, so now in any equation where there is an x, we can replace it with a over 3y. So let's go over here now. Let's go over here. And actually, you know what? I know I said we were going to solve for all the x's, but how about we just solve for y here? Because if we get y by itself, y is going to be written in terms of x's. And then we could plug something in over here, and we could figure out, what a is in terms of x's. So let's just solve for y now, actually. So we're going to subtract 2x from both sides. So we got 300 minus 2x. And that's equal to 5 times y. So now the opposite of times, that'd be divide. So divide by 5. We divide the other side by 5. So now we know that y is equal to 300 minus 2x over 5. Okay, so we're going to keep that bit of information in mind because now we can change y so that's strictly in terms of x's. So we're going to do the same thing over here. We're going to solve for a. So since we're going to solve for a, we're going to add 3x to both sides. We're going to add 3x, add 3x. So that means we got 10a is equal to 400 plus 3x. Okay. So now I want a by itself, so I can divide by 10. Basic algebra stuff. So that means a would equal 400 plus 3x over 10. So now that I know a is this in terms of x, I can replace this a with its x values. So now that we know all three of these bits of information, let's go ahead and plug stuff in and see what happens. So we got 400 plus 3x divided by 10. All of that divided by 3 times 300 minus 2x over 5. Okay, and all of that is equal to x. So right now, I know this looks like a big mess, but here's the thing. Here's the thing. Now we only have one variable. So unlike before, where we had, 3 variables or 2 variables in our equations, we were going to have to jump back and forth and figure out what they were all the time. No. Now we have this in terms of x, and so from here, we would be able to use algebra to start moving things around. So, we could multiply by 3 times whatever, multiply by the 10 and the 5, cancel those. Everything we need in order to solve this equation is right here in this final version that we've put together. From here, everything is just reverse PEMDAS or SADMAP until we can get an answer. And once we know what x is, well, we can figure out a because we'll be able to plug in x and that'll give us a. And we'll be able to find y because we'll be able to plug in x and find y. So this art of taking equations and either plugging them into each other or, using some algebra to move them around so that we can plug into each other, this is what's going to be super helpful, especially when it comes to something like, chemistry or physics. Now, this is one half of it. The other half, and this is going to be the half that you'll probably see a little bit more often, is this idea of, well, why don't we just plug things into other things? So let's say we have f of x. So f of x, so let's say that this is the height function, right? Okay, so let's say we have the acceleration times x squared plus the initial velocity times x plus the initial x value. So it's okay. Okay, so let's say I give a is 3 and give the initial velocity is 1. So okay, we can plug in those numbers and we can even plug in the initial x value. Let's say that's 3. So we get 3x squared plus 1x plus 3. And you're thinking to yourself, okay, so I'm just plugging those in. That's fine. But then I'm going to throw you for a curveball. So let's say that x is 2 times t plus 1. Now, if you've done function composition, you might think to yourself, oh, okay, so I could just plug, the 2t plus 1 into everywhere where there's an x. And yes, you can. You can do that. And if I didn't give you a t, I would probably tell you that's a good idea. But if I give myself a t value, let's say t equals 3. Okay, well, now all of a sudden, it's very easy to just plug in that 3 and just figure out what number x is. So if x is, 2 times 3 would be 6. 6 plus 1 is 7. So x is 7. Now we can just plug 7 into this. So, it's 3 times 7 squared plus 1 times 7 plus 3. So you see how if we'd have plugged this in early, if I would have seen this and go, oh yeah, let's plug that right in right away, that would have given me so much more algebra to work with. I would have had to multiply 2t plus 1 by itself, then I would have had to multiply by 3, then I would have had to multiply by 1, then I would have had to add all my like terms, and only after all of that would I have been able to plug in the t. So don't jump the gun whenever you get a word problem and they tell you that there's a relationship between them. Wait and figure out all of the things that you can plug in before you try to plug into the big equation. So this is the numerical version of formula substitution. You just grab the number, plug it in to what you do know, so that when you plug it into other stuff, it'll be much easier along the way. I know this might seem obvious to some of you that are watching right now, but there are many students who, whenever they get to big word problems, they'll have formulas like this, and they won't write down, what the letter is before they start plugging stuff in. So they'll wind up with tons and tons and tons of messy algebra. They're not sure what to do. They're not sure how everything works. There's so many steps, and they're so exhausted by the time that they're finally done that they don't recognize they could just plug the numbers in quickly and easy by just setting it up beforehand and then just writing down what all of the letters are. Don't do that to yourself. Just write down all of the numbers you do know and then plug them in one at a time until you can finally find an answer. It's a much easier and faster way to do it, where you don't have to do so many steps, or at least not so many algebra steps. So just something to keep in mind. So now let's go ahead and cut back to the lesson stuff. So now we're going to talk about function algebra. So function algebra. So you're probably used to doing this, but you're probably not used to thinking about doing it very much. So to give you an example of what I'm talking about, so there is an equation called the ideal gas law. So the ideal gas law states that PV equals N times R times T. And I am going to be completely honest, I don't remember what all of these letters mean off the top of my head, but I do know that in your classes, they are going to let you know, hey, this is what each letter is. So sometimes you're going to have, these four, and you're going to need to solve for T. Or maybe they'll give you these four, and then you need to solve for P. Or, whichever letter it is that they leave off. You're going to be having all but one of them, because that's how an equation you need to solve works. You're given all but one of them, unless they give you multiple equations. And in that case, you just need to solve for however many letters you have. So let's say they give you all but one of these. Let's say they tell you that P equals 3, R equals 2, T equals 3, and N equals 4. So we're going to plug all these in. So P is 3, so we got 3 times V equals, so N is 4, times R, which is 2, times T, which is 3. So 4 times 2 is 8. 8 times 3 is 24. So we got 24 equals 3V. And if we divide both sides by 3, then we can get V is equal to 8. I'm sure there's probably a chemist somewhere out there watching this who's going, wait a minute, V being 8, that's weird. That's okay. Don't worry about it. It's okay. These are just numbers for the sake of a problem. So as you can see, we can plug all of these in, and then we can do a little algebra to solve it. But what if I told you that most chemistry people don't do that? Most chemistry people don't have to go through all the algebra steps every time. And the reason they don't is because what they'll do is they'll make a formula that just solves for whatever they're looking for at the time. So instead of plugging in all the numbers into the same one over and over and over again, what they can do is they can go, okay, so I'm missing V, so what I'm going to do is I'm just going to divide by P off the bat. So divide by P off the bat, so V is equal to nRT over V. And if we, I just want to point out, if we wanted to get P by itself, we could do the same thing by just dividing by V. Oh, I accidentally divided by V over here. I'm so sorry. That is supposed to be a P in yellow. We didn't divide by V over there. We divided by P. And so if we were dividing by V, that would give us P equals nRT divided by V. So now that I have these individual formulas, I don't have to reference the original whenever I don't have a volume. So V is volume. So if I know the number of moles, R, I don't remember what R is, the temperature, and P is the pressure. Now if I just want to know the volume and I know those 4 other things, I can just plug those in and get volume lickety-split. I can just multiply, divide, all done. I don't have to do any algebra beyond that. And the same goes for P. So P, if I know the P is pressure, I believe, then the number of moles times R, which I believe is the gas constant, the ideal gas constant, but I could be wrong. Don't quote me on that. Times the temperature divided by volume, that can give me P. However, I can also do this in reverse. So let's say that the question didn't want me to solve for P or V. So if it didn't want to solve for P or V, let's say it wanted us to solve for R. So if it wanted us to solve for R, we'd need to divide by N times T. So we divide by N times T on both sides. So the N's and the T's would cancel. And I would get R equals PV over NT. So with that being the case, now if I need R, I don't have to reference the original anymore. I can just say, oh, well, R is this thing over here. I know it's this thing over here because I did the algebra ahead of time, and I have a nice, neat little formula I can reference. And you could do this for all of the letters. Basically, whatever the goal is, if you can do the algebra ahead of time, once you go to plug in the numbers, now you won't need to do any algebra anymore. And it's not just algebra for one question. Now, for the rest of your life, if ever you need to solve for I believe that's the ideal gas constant. So if ever you need to solve for R, P, or V, you can do that using these formulas. You don't have to remember the original anymore. You have these guys written down instead. And since you have these guys, you can solve for all three of these. And you can use them to get back to the original equation anyway. Because if you take this guy, and sorry, brush. If you take this equation, you multiply by V on both sides, guess what? You're going to get PV equals nRT. And now we're right back where we started at that ideal gas equation. And we can do it just using any of these formulas, really. So being able to move a formula around using algebra before you plug any numbers in is really helpful in the sense of it's going to save you time in the future. Because once you write down, it's like, oh, so if I just do it like this, now I can just plug in numbers for the rest of my life. Yes, because while I'm more of a pure math guy myself, I actually like moving around the algebra. So that's part of the reason why I did this program, is because I like explaining all of this algebra and every little step to you guys when you are learning. I know that you guys don't want to have to do that every single day of your life for the rest of your life. So instead, so you don't have to do that. You can just make your formulas. You can just make your formulas using the original equation you start with, move them around a bit, and now, you just pick whichever one you need to solve for. This is why formula algebra is really useful, especially in things like chemistry, dimensional analysis, which is in both chemistry and physics. And engineering has a lot of this, where you just play around with the formula until you can make something that's a short, easy, quick thing to solve for. It's a really nice thing to be able to do. So I'm just going to go ahead and go back to the thing now. So that's what formula algebra is in a nutshell. I believe, yeah. So, it's also good for business whenever you have certain equations that do certain things. Of course, whenever we go into the synchronous hours, I will be talking about these. We will go over these together. And we'll look at some other situations where formula algebra can really help you make your life much faster and easier in a lot of small ways. Because even if you just do it in a small way here and there, you're still getting the maximum amount of efficiency for your time, and you're making it so you're working smarter, not harder, which we could all use a little bit of making things easier in our day-to-day life, especially when it comes to math. So that's all the stuff for today. I will see you guys in the next lesson, and you have an awesome day until then. Bye-bye.